the first question is about ALS, also known as Lou Gehrig's disease. Though I've heard recent debate about whether or not he actually had this or if he had something related, but in any case. So it asks about the two principal mechanisms described in box 13.1 that lead to cell death in this particular disorder. So we're supposed to talk these out. So Danielle, you kind of got the whole question. So. I think it's just SID itself. You guys agree? Disagrees? Get anything else? This is one where there's not a ton of, I don't want to say there's not a lot of information. There's a ton of study of this disorder. It is a well-studied disorder, and it's not super common, but it's not super uncommon either. And one of the, and these are sort of the two main causes that have been identified, and they may or may not be directly related to one another. So there's some indication that part of the way excitotoxicity works is through oxidative damage, but not all the oxidative damage is caused by excitotoxicity, and so it's kind of muddy. And but it is a really interesting disorder for these two regions. So one of these, so one of the explanations is this idea of excitotoxicity, where you're literally just exciting these neurons to death. So there's overproduction of glutamate. That glutamate super hyperstimulates these neurons. Glutamate is a excitatory neurotransmitter. We mentioned it all the way back in chapter 5 as one of the more common excitatory neurotransmitters. But if you got too much of this stuff, it can lead to overstimulation and cell death. Perhaps related to this is this idea that one of the ways that it can lead to overstimulation and cell death is through oxidative damage. But then there's also this whole mechanism where you get this damage to the superoxide dismutase gene, which then results in elevated levels of free radicals, and so you get a lot of cell damage as a result of these free radicals. You guys, do you know what free radicals are? Do you understand the idea with these? I'm seeing some yeses. I mean, so the idea here is you have some extra electrons. And these extra electrons, so you can have superoxide, for example, is literally just I know some people said yes, but I'm going to tell you anyway. Superoxide, so this is regular oxygen, right? Superoxide is written kind of like this. I can never remember which one goes where, so I'm just doing it that way. So that dot means it has an extra electron, and that extra electron gives it a negative charge. But that extra electron makes this oxygen molecule crazy reactive. And so if it gets near organic molecules, it can donate its electron to those organic molecules, which then destabilizes the covalent bonds that holds them together. And the result is you just have entire chains of carbon breaking apart. So literally the fundamental molecules that are making up the cell structure are breaking apart as a result of this oxidative damage caused by these free radicals. So when you're taking antioxidants, a lot of, my wife is just popping vitamin C like crazy anymore, which is an antioxidant. I'm not entirely sure that the data are really good that it really does prevent colds or disorders, but it certainly isn't hurting you. The thing about vitamin C, though, is that it is one of the things it does is it is a free radical scavenger. So it is a molecule that's really good at picking up these extra electrons and kind of containing them and trapping them away, which is one of the reasons antioxidants are thought to be so good. So vitamin C, several of the other vitamins are also functioning as free radical scavengers like that. But anyway, this is the idea here, is that there's some manner of excitotoxicity and or damage to our oxidative control mechanisms, our antioxidant control mechanisms, I guess, that are leading to cell damage and ultimately to the death of the neurons that control your musculature. And it results in just a really debilitating disorder. Ultimately, Yeah, so so Stephen Hawking, Lou Gehrig, a lot of these people, you've certainly seen how aggressive these kinds of disorders are. Stephen Hawking had a really low, like slow onset one, which is how he was able to live as long as he did. Most of the time, ALS is unfortunately much more rapidly progressing. In a matter of a few years, you kind of go from functional to losing control of your diaphragm, and at that point, you're done. And we're out of time. So sorry, I got going on ALS again. So we'll have to pick up with number 2. We'll go through the rest of these on Wednesday, and then we will start in chapter 14. So you can expect those slides to go up today or tomorrow.